Far below the surface of the ocean, the seafloor is not flat. It is covered by thousands of underwater mountains rising from the deep. Many of these mountains do not stand alone. Instead, they form long chains that stretch across vast sections of the ocean floor, sometimes extending for hundreds or even thousands of kilometers. When viewed on a global map, these chains appear as repeating lines of seafloor peaks crossing entire ocean basins. Across the Pacific, Atlantic, and Indian Oceans, these seamount chains create a hidden geographic network beneath the water. Some chains run through the centers of ocean basins. Others appear near continental margins or across remote regions of the open ocean. Modern seafloor mapping now reveals how widespread these formations are and how they are arranged across the planet. In this video, we look at the global distribution of seamount chains and how these underwater mountain systems are organized across the world ocean. If you enjoy calm science content like this, consider subscribing to Quiet Facts, like the video, and leave a comment below about what ocean topic you would like to see next. Seamount chains appear across the global ocean floor as repeated linear groupings of underwater elevations. Their placement can be represented through a reference grid that organizes positions across major ocean basins. This grid functions as a spatial framework used to situate individual chains relative to planetary ocean geography. Locations are typically indexed using latitude and longitude coordinates that align with global bathymetric mapping systems. Large-scale ocean basins provide the primary reference fields in which seamount chains are positioned. The Pacific Ocean contains the greatest number of mapped chains, distributed across central, western, and eastern basin sectors. The Atlantic Ocean includes smaller but clearly defined chain groupings arranged across northern and southern basin regions. The Indian Ocean presents several chain networks distributed between mid-basin and margin-adjacent sectors. Southern ocean sectors include additional chains positioned along high-latitude oceanic regions. The global reference grid also incorporates basin subdivision systems used in seafloor mapping. These subdivisions include central basin interiors, transitional boundary regions, and extended basin margins. Seamount chains can be indexed within these subdivisions to indicate relative spatial grouping without reference to origin or geological development. Each chain occupies a coordinate-defined segment of the ocean floor that fits into the broader grid framework. Global bathymetric surveys and seafloor mapping initiatives contribute to the refinement of this grid-based reference structure. Multi-beam sonar surveys and satellite-derived seafloor models provide consistent positional data for thousands of mapped seamount features. These datasets allow chain groupings to be catalogued according to spatial alignment and geographic placement across the planetary ocean surface. Within the global reference grid, seamount chains form identifiable geographic patterns across multiple ocean basins. Each chain is represented as a sequence of mapped seafloor elevations arranged along consistent spatial tracks. The grid framework provides a stable positional system used to catalog and compare these chains across the world ocean. The Pacific Ocean contains the largest concentration of seamount chains on the global ocean floor. These chains appear across wide sectors of the basin and form several distinct spatial groupings. Their distribution extends from the western Pacific margins across the central basin and toward eastern Pacific sectors. Each grouping occupies a defined geographic band within the overall Pacific Basin framework. Central Pacific regions contain numerous chain alignments positioned across large mid-basin areas. These alignments extend across broad stretches of ocean floor and form long sequences of mapped seamount elevations. Several chain systems appear across this interior basin region and create repeated linear arrangements that span thousands of kilometers of seafloor. The Central Basin sector therefore represents one of the most densely catalogued areas for seamount chain distribution. Western Pacific sectors also contain extensive chain groupings arranged near island arc regions and deep ocean basins. Many of these chains appear as long, parallel sequences distributed across multiple subregions of the basin. Their mapped positions follow identifiable geographic corridors across Western Pacific seafloor terrain. These corridors define regional concentration sectors that appear consistently in global bathymetric datasets. Eastern Pacific areas contain additional chain groupings positioned along wide basin zones extending toward continental margins. These chains appear in several separated belts distributed across eastern basin sectors. The belts occupy large geographic fields that correspond to mapped bathymetric reference regions of the eastern Pacific floor. High latitude Pacific sectors contain further chain distributions extending toward northern and southern basin limits. These areas include additional seamount sequences mapped along wide oceanic regions approaching polar transition zones. The Pacific Basin, therefore, contains multiple concentration sectors where seamount chains occur in repeated geographic groupings across different parts of the basin. When these sectors are viewed together, the Pacific Ocean forms the most extensive global region of seamount chain distribution. Numerous chain groupings appear across central, western, eastern, and high-latitude sectors of the basin. Each grouping occupies a distinct spatial sector within the broader Pacific Basin reference framework. Seamount chains in the Atlantic Ocean appear in several distributed reference zones across the basin floor. These zones extend through northern, equatorial, and southern Atlantic sectors. Each zone corresponds to mapped groupings of seafloor elevations that form recognizable chain arrangements across the basin. The Atlantic Basin contains fewer chains than the Pacific, yet the spatial organization of its chains remains clearly defined within global bathymetric mapping systems. Northern Atlantic sectors include multiple chain groupings located across open ocean regions and basin transition areas. These chains appear as aligned sequences of seamounts, distributed across wide seafloor corridors. Their mapped positions occur across both western and eastern parts of the northern basin. Several chain alignments extend across long geographic distances and occupy identifiable segments of the Atlantic seafloor grid. Equatorial Atlantic regions contain additional chain distributions positioned near the central basin zone. These chains occur across large ocean floor areas that lie between the northern and southern Atlantic sectors. The alignments appear as linear sequences of mapped seamount features distributed across mid-basin reference regions. The equatorial zone forms a transitional reference area linking chain distributions across the broader basin. Southern Atlantic sectors contain further chain groupings extending across large areas of the basin floor. These groupings appear across several distinct geographic sectors that correspond to mapped bathymetric regions. Many of these chains occur in separated clusters distributed across southern basin interiors and outer basin margins. Some are all listeners. Skies are listen. Across the Atlantic Ocean, these northern, equatorial, and southern zones together define the principal reference framework for seamount chain distribution. Each zone contains mapped sequences of underwater elevations arranged in recognizable geographic alignments. The basin-scale reference zones allow these chains to be catalogued according to spatial placement across the Atlantic Ocean floor. Seamount chains in the Indian Ocean occur across several large distribution sectors positioned between continental margins and central basin regions. These sectors include western, central, and eastern parts of the ocean basin. Each sector contains mapped sequences of underwater elevations arranged in identifiable geographic alignments. The Indian Ocean basin, therefore, forms a distinct reference field for global seamount chain placement. Western Indian Ocean sectors include several chain groupings, distributed across wide ocean floor regions located east of the African continental margin. These chains appear as a lined series of seamounts extending across large seafloor areas. Their mapped positions form recognizable corridors that occupy defined geographic sectors of the basin. Some chains extend across long distances and appear as continuous linear groupings across the Western Basin grid. Central Indian Ocean regions contain additional chain alignments located across mid-basin areas between the western and eastern sectors. These alignments appear across large sections of open ocean floor and form sequences of mapped seamount features arranged along consistent spatial tracks. The Central Basin sector therefore represents an intermediate distribution region linking chain groupings across the wider ocean basin. Eastern Indian Ocean sectors contain further seamount chain distributions, positioned across basin regions extending toward the Australian continental margin. These chains appear as separated alignments distributed across multiple geographic zones. Their mapped positions correspond to bathymetric reference regions used in large-scale seafloor surveys. Southern parts of the Indian Ocean also include additional chain distributions extending toward high-latitude ocean sectors. These groupings appear across wide seafloor areas approaching the boundary regions of the Southern Ocean. Across the Indian Ocean basin, these western, central, eastern, and southern sectors collectively define the principal spatial framework for seamount chain distribution within this part of the global ocean. Seamount chains in the Southern Ocean appear across several high-latitude reference fields surrounding the Antarctic continental region. These fields form part of the global spatial framework used to catalog underwater mountain chains across the ocean floor. The Southern Ocean basin connects with the Pacific, Atlantic, and Indian Oceans, and seamount chains located in this region occupy transitional sectors between these major ocean basins. Several chain groupings occur across wide ocean floor areas positioned along the circum-Antarctic basin system. These groupings appear as sequences of mapped seamount elevations arranged along consistent geographic alignments. Their distribution extends across multiple sectors surrounding the Antarctic continental margin. The mapped positions of these chains correspond to bathymetric regions defined in global seafloor mapping systems. Southern Ocean chain reference fields also include mid-basin sectors located between major oceanic ridge systems and deep ocean basins. Within these sectors, seamount chains appear as distributed linear groupings across large seafloor areas. These chains occupy identifiable spatial corridors that extend across wide sections of the ocean floor at high southern latitudes. Additional chain groupings occur near oceanic transition zones, where the Southern Ocean connects to adjacent Pacific, Atlantic, and Indian Basin regions. In these areas, mapped seamount chains appear as extended alignments that continue across basin boundaries. These alignments form part of broader cross-basin distribution patterns recorded in global bathymetric datasets. Across the Southern Ocean, these circum-Antarctic, mid-basin, and transitional sectors together form the principal reference fields for seamount chain placement at high southern latitudes. Each field contains mapped sequences of underwater elevations positioned within defined geographic regions of the Southern Ocean basin. These reference fields allow seamount chains in this region to be indexed within the broader global framework of ocean floor spatial distribution. A cross-basin distribution map places seamount chains from multiple ocean basins into a single spatial reference system. This mapping approach aligns chain locations across the Pacific, Atlantic, Indian, and Southern Asian basins. The resulting map provides a unified geographic framework used to catalog underwater mountain chains on a planetary scale. Each mapped chain appears as a sequence of seafloor elevations positioned along identifiable spatial tracks. Cross-basin mapping organizes these chains using consistent coordinate systems applied across global bathymetric datasets. Latitude and longitude indexing allows chain alignments to be positioned relative to the boundaries of major ocean basins. These coordinate references remain consistent across different mapping surveys and seafloor observation programs. The standardized grid structure allows individual chains to be located within a global ocean floor reference field. Large-scale bathymetric compilations contribute to the development of cross-basin chain maps. Multi-beam sonar surveys, satellite-derived bathymetric models, and oceanographic mapping programs supply positional information for thousands of seamount features. These datasets are combined to produce comprehensive maps that show the geographic distribution of seamount chains across the world ocean. The mapping process records spatial alignment and relative location, while excluding geological interpretation. Cross-basin maps reveal that many seamount chains occupy long linear corridors extending across wide areas of ocean floor. These corridors appear within a single basin or span boundary regions between adjacent basins. The mapped sequences appear as repeated chains of underwater elevations arranged along extended geographic tracks. When displayed together, the chains from multiple basins form a global pattern of seafloor elevation sequences distributed across the air of every sea and the size of black sea fly, even far of the big tents. The trains from such lanes of seafloor end with complex casts. The cross-basin distribution map therefore functions as a global reference framework for organizing seamount chain placement across the entire ocean floor. Central Pacific regions contain one of the largest networks of seamount chains in the global ocean. These chains appear across wide areas of the basin interior and form extensive groupings of underwater elevations. The network occupies large mid-basin sectors positioned far from continental margins. Numerous mapped Central Sea Sound sequence extend across Central Pacific reference sectors. These chains appear as repeated alignments of seafloor elevations arranged along extended geographic tracks. Individual chains may extend across large distances of the basin floor while maintaining consistent spatial alignment. These alignments form identifiable corridors across the Central Pacific seafloor grid. The Central Pacific network also includes multiple parallel chain groupings distributed across adjacent basin sectors. These groupings appear as sets of aligned seamount sequences, positioned within neighboring geographic zones. In many areas, several chains occur within the same regional sector, while remaining separated by large areas of open ocean floor. This arrangement produces a pattern of distributed but clearly grouped chain systems. Large-scale bathymetric surveys have catalogued thousands of seamount features across the Central Pacific Basin. These surveys record the geographic placement of seamount chains and organize them into mapped network sectors. Each chain appears in seafloor datasets as a sequence of underwater elevations arranged along defined spatial tracks. Across the Central Pacific Basin, these networks form a broad system of chain groupings distributed across mid-ocean regions. The network includes numerous individual chains positioned within distinct geographic sectors of the basin interior. Each chain occupies a mapped segment of the seafloor grid used in global ocean floor reference systems. The Central Pacific therefore represents one of the most extensive network regions for seamount chain distribution within the world ocean. Western Pacific regions contain several prominent groups of seamount chains arranged across wide ocean floor sectors. These groups occupy areas extending from the Central Pacific Basin toward the western margins of the ocean. Numerous mapped seamount sequences appear across these regions, forming large chain systems distributed across the western Pacific seafloor. Several alignment groups extend across long geographic corridors within this basin sector. These chains appear as linear sequences of underwater elevations positioned along consistent directional tracks. Individual chains can span large distances across the ocean floor while maintaining recognizable spatial orientation. These repeated alignments define several major chain groups recorded in seafloor mapping datasets. Multiple chain groups occur across adjacent Western Pacific sectors. In some regions, parallel chains appear across neighboring geographic zones, separated by large areas of deep ocean floor. These parallel arrangements form clusters of alignment groups that occupy broad sections of the Western Pacific Basin. The spatial separation between chains allows each alignment group to remain identifiable within regional mapping frameworks. Western Pacific chain groups also occur near island arc regions and deep ocean basin interiors. These groups extend across large seafloor fields, positioned between island systems and open ocean areas. Mapped sequences of seamounts appear along extended tracks across these regions and form continuous chain alignments recorded in bathymetric surveys. Regional mapping programs and global seafloor datasets document the placement of these alignment groups across the Western Pacific Basin. Thousands of mapped seamount features contribute to the identification of chain sequences within this ocean region. The alignment groups represent organized geographic patterns of seamount distribution across the Western Pacific seafloor grid. Eastern Pacific regions contain several wide reference bands where seamount chains are distributed across the basin floor. These bands extend across ocean sectors position indicated by the desert of silent Pacific interior regions and the continental margins of the Americas. Numerous mapped sequences of seamount elevations appear within these geographic bands, forming identifiable chain systems distributed across Eastern Pacific seafloor areas. Several chain systems occupy elongated geographic bands that extend across large portions of the Eastern Pacific Basin. These systems appear as repeated alignments of underwater elevations arranged along extended spatial tracks. Individual chains may extend across hundreds or thousands of kilometers of ocean floor while maintaining consistent orientation. The alignment of these chains forms recognizable reference bands within regional seafloor mapping frameworks. Multiple chain bands occur across neighboring Eastern Pacific sectors. In some areas, separate chains appear across parallel geographic zones, divided by broad regions of deep ocean terrain. These parallel arrangements produce sets of chain bands positioned across adjacent parts of the basin. Each band contains sequences of mapped seamount features aligned along defined geographic corridors. Eastern Pacific reference bands also include chain systems located near basin transition regions approaching continental margins. In these sectors, seamount chains appear across wide ocean floor areas, positioned between mid-ocean basin interiors and continental boundary regions. The chains remain identifiable as extended alignments of seafloor elevations recorded in bathymetric surveys. Regional mapping programs and global seafloor datasets provide detailed records of these Eastern Pacific chain bands. Where 10-4. Thousands of seamount features are catalogued within these bands and appear as repeated sequences across mapped ocean floor sectors. The reference bands represent organized geographic zones used to classify seamount chain placement across the Eastern Pacific Basin. North Atlantic regions contain several defined fields where seamount chains appear across the basin floor. These fields occupy ocean sectors extending between continental margins of North America, Europe, and Africa. Numerous mapped seamount sequences occur across these areas and form identifiable chain systems within the Northern Atlantic Basin. The distribution of these chains creates distinct spatial fields recorded in global bathymetric datasets. Several chain systems extend across wide ocean floor regions, positioned in the interior of the North Atlantic Basin. These chains appear as linear sequences of underwater elevations, aligned along consistent geographic tracks. Individual chains may extend across long distances of seafloor, while maintaining a recognizable directional arrangement. These extended alignments define large distribution fields within the northern part of the Atlantic Basin. Additional chain systems appear across transitional regions located between the basin interior and continental boundary sectors. In these areas, seamount chains occur as grouped sequences distributed across broad ocean floor zones. Multiple chains may appear within the same regional field, while remaining separated by large stretches of deep ocean terrain. This arrangement produces identifiable clusters of chain systems across several northern Atlantic sectors. North Atlantic chain fields also include sequences positioned across oceanic plateau regions and surrounding basin areas. In these locations, mapped seamount elevations form organized chains that extend across wide sections of seafloor. These chains contribute to the broader distribution pattern of seamount systems recorded in regional mapping surveys. Global seafloor mapping programs document thousands of individual seamount features across the North Atlantic Basin. These mapped elevations are organized into chain systems that occupy distinct geographic fields across the ocean floor. The distribution fields provide a basin-scale framework used to catalog seamount chain networks across the northern Atlantic Ocean. South Atlantic regions contain several cluster areas where seamount chains are distributed across the basin floor. These cluster regions extend between the continental margins of South America and Africa, and include large sections of the southern Atlantic Basin interior. Numerous mapped sequences of underwater elevations appear across these areas and form identifiable chain groupings within regional seafloor mapping frameworks. Several chain clusters occur across wide ocean floor sectors, positioned in the central and eastern parts of the South Atlantic Basin. These clusters consist of multiple seamount chains arranged across neighboring geographic zones. Individual chains appear as aligned sequences of seafloor elevations that extend across long spatial tracts. The presence of several chains in proximity creates concentrated cluster regions across portions of the basin. Additional cluster areas occur across western South Atlantic sectors located closer to the South American continental margin. In these areas, mapped seamount sequences appear as grouped alignments distributed across broad ocean floor fields. Multiple chains may occupy the same regional sector, while remaining separated by large areas of deep ocean terrain. This arrangement produces distinct clusters of chain systems across western basin zones. Southern parts of the Atlantic Basin contain further cluster regions, extending toward high-latitude ocean sectors. In these regions, chains appear across wide seafloor areas positioned between basin interior regions and southern oceanic transition zones. The mapped alignments of seamount elevations form additional cluster groupings within the southern Atlantic Basin. Global bathymetric surveys document many thousands of seamount features across the South Atlantic Ocean. These mapped elevations are organized into chain systems that occupy defined cluster regions across the basin floor. The cluster regions provide a spatial framework used to catalog seamount chain groupings across the southern Atlantic Ocean basin. The Indian Ocean basin contains several network zones where seamount chains appear across large areas of the ocean floor. These zones extend between the continental margins of Africa, Asia, and Australia, and include broad sections of the basin interior. Numerous map sequences of underwater elevations occur across these regions and form identifiable networks of seamount chains within the Indian Ocean. Western Indian Ocean sectors include network zones located across ocean floor areas east of the African continental margin. Several seamount chains appear across these regions as aligned sequences of underwater elevations extending along defined spatial tracks. Multiple chains may occupy the same regional sector while remaining separated by wide areas of deep ocean terrain. This spatial arrangement produces organized chain networks distributed across the Western Basin. Central Indian Ocean regions contain additional chain network zones positioned across large mid-basin areas. In these sectors, mapped seamount elevations appear as repeated sequences arranged along extended geographic alignments. Several chains occur across neighboring parts of the basin interior, and together form broad network groupings across central ocean floor sectors. Eastern Indian Ocean areas also contain chain network zones extending toward the Australian continental margin. In these regions, seamount chains appear across multiple geographic sectors distributed across the basin floor. The mapped sequences form extended alignments of seafloor elevations that define regional chain networks recorded in bathymetric datasets. Across the Indian Ocean basin, these western, central, and eastern sectors collectively form the principal network zones for seamount chain distribution. Thousands of mapped seamount features contribute to the identification of these chain networks. Each network zone represents a basin-scale grouping of seamount chains positioned across defined sectors of the Indian Ocean seafloor. Longitudinal chain alignment bands describe seamount chains arranged primarily along north-south-oriented tracks across the ocean floor. These bands consist of sequences of underwater elevations that follow directional paths roughly parallel to lines of longitude. The arrangement produces extended alignments that appear across large oceanic regions in global seafloor mapping datasets. Several longitudinal bands occur across major ocean basins and extend across wide sections of deep ocean terrain. Individual chains within these bands appear as repeated sequences of mapped seamount features, positioned along consistent directional tracks. The alignment of these features creates recognizable north-south-oriented corridors within regional bathymetric grids. Multiple chains may occupy the same longitudinal band while remaining separated by measurable geographic intervals. Longitudinal alignment bands appear in different basin environments, including mid-ocean interiors and transitional basin sectors. In many cases, chains within these bands extend across large portions of the ocean floor and remain identifiable over long geographic distances. The continuity of these alignments contributes to the classification of longitudinal chain groupings within seafloor reference systems. Global bathymetric mapping programs record the positions of these chains through coordinate-based survey data. Each mapped seamount within a chain occupies a defined position along a north-south-oriented spatial track. When multiple seamount sequences follow similar directional paths, they form alignment bands that extend across broader ocean floor regions. Within these longitudinal bands, seamount chains appear as organized geographic patterns distributed across several ocean basins. The bands represent directional reference structures used to categorize the orientation of chain systems in global seamount distribution studies. Each band contains sequences of underwater elevations arranged along north-south alignment corridors across the mapped ocean floor. Latitudinal chain distribution rows describe seamount chains arranged along east-west-oriented tracks across the ocean floor. These rows follow directions that align approximately with lines of latitude in global coordinate systems. The arrangement produces sequences of underwater elevations that extend horizontally across regional seafloor grids. Several latitudinal rows occur across different ocean basins and extend across large sections of deep ocean terrain. Within these rows, individual chains appear as repeated sequences of mapped seamount features, positioned along consistent east-west directions. Each chain forms a linear arrangement of underwater elevations distributed across defined geographic sectors of the ocean floor. Or multiple chains may occupy the same latitudinal row while remaining separated by measurable distances along the seafloor. In some areas, parallel rows appear across neighboring basin sectors, creating a pattern of horizontally oriented seamount sequences. These arrangements form recognizable bands within bathymetric mapping frameworks used to catalog seafloor features. Latitudinal rows appear across both basin interiors and transitional ocean floor regions. Chains located in these rows may extend across long distances while maintaining consistent east-west alignment. The repeated positioning of seamount features along these tracks contributes to the identification of row-based distribution patterns across mapped ocean basins. Global bathymetric surveys record the geographic placement of these chains through coordinate-based mapping systems. Each seamount within a chain occupies a defined position along an east-west oriented spatial track. When multiple chains follow similar directional paths, they form latitudinal rows that extend across wider ocean floor regions. These rows represent directional reference structures used to categorize seamount chain orientation in global distribution mapping. Each row contains sequences of underwater elevations arranged along horizontal alignment tracks across the mapped ocean floor. The diagonal chain alignment corridors consist of seamount chains arranged along slanted directional directions across the ocean floor. These corridors follow orientations that are neither strictly north, south, nor east-west. Instead, the chains extend across the seafloor along angled paths that intersect latitude and longitude lines at consistent offsets. The result is a pattern of diagonally aligned seamount sequences, distributed across several ocean basins. Many of these corridors extend across wide ocean floor regions and include long sequences of mapped seamount elevations. Individual chains appear as repeated underwater features positioned along extended spatial tracks that cross regional bathymetric grids at an oblique angle. When multiple chains follow similar directional paths, they form identifiable diagonal corridors within global seafloor mapping systems. Several diagonal corridors occur across different basin sectors, including mid-ocean interiors and basin transition regions. Chains located in these corridors may span large distances across the seafloor while maintaining a consistent directional orientation. The repeated arrangement of seamount features along these angled tracks produces organized alignment corridors across mapped ocean floor areas. Bathymetric datasets record the positions of these chains through coordinate-based seafloor surveys. Each seamount within a chain occupies a defined geographic position along the diagonal path of the alignment corridor. When multiple chains appear along similar angled directions, they form corridor groupings that extend across broader seafloor regions. Within these diagonal corridors, seamount chains appear as structured geographic patterns distributed across large sections of the global ocean floor. The corridors provide directional reference frameworks used to classify chain orientation in global seamount distribution mapping. Each corridor contains sequences of underwater elevations arranged along consistent angled alignment tracks across the mapped seafloor grid. Parallel chain grouping sets describe arrangements in which multiple seamount chains extend across the ocean floor along similar directional paths. Each chain forms a sequence of underwater elevations aligned along a linear track, and several of these tracks appear side by side across neighboring areas of seafloor. The repeated orientation of these chains produces sets of parallel alignments distributed across regional ocean sectors. These grouping sets occur across several ocean basins and occupy wide sections of deep ocean terrain. Within each set, individual chains appear as separate lines of mapped seamount features, positioned at relatively consistent spacing from adjacent chains. The geographic separation between chains allows each alignment to remain identifiable while contributing to the broader grouping pattern. Parallel sets often extend across long distances of the ocean floor. Chains within these sets may span hundreds or thousands of kilometers while maintaining similar directional orientation. The repeated arrangement of aligned seamount sequences produces organized spatial structures across mapped seafloor grids. These structures are visible in regional bathymetric datasets that catalog large numbers of underwater elevations. Multiple parallel sets may appear across neighboring parts of an ocean basin. In such areas, several groups of aligned chains occupy different geographic sectors while maintaining consistent directional patterns. The presence of these repeated alignment sets creates recognizable frameworks used in seamount distribution mapping. Global seafloor surveys record the geographic placement of individual seamount features that compose these chains. When chains appear in adjacent alignments following similar directional tracks, they form parallel grouping sets within the broader seafloor reference system. These sets represent spatial patterns of aligned seamount sequences distributed across mapped regions of the ocean floor. Multi-chain alignment sectors refer to ocean floor regions where several seamount chains occur within the same geographic area and follow broadly similar directional layouts. Each chain forms a linear sequence of underwater elevations mapped along a defined spatial track. When multiple chains occupy the same regional sector, their alignments collectively form a structured arrangement across that part of the ocean floor. These sectors appear across different ocean basins and include large sections of deep ocean terrain. Within each sector, individual chains remain identifiable as separate sequences of mapped seamount features. The chains may run along similar directional orientations while remaining separated by measurable geographic intervals. This arrangement produces regional groupings of aligned chains distributed across mapped seafloor grids. In some sectors, 3 or more chains appear across adjacent ocean floor zones. These chains extend across wide seafloor areas and maintain recognizable alignment patterns along extended geographic tracks. The repeated positioning of several chains within a single sector creates multi-chain alignment fields that are recorded in bathymetric datasets. Multi-chain alignment sectors can occur across basin interiors as well as transitional ocean floor regions. Chains within these sectors may span large distances across the seafloor while preserving consistent directional orientation. Their collective arrangement forms identifiable patterns of repeated chain alignments within regional seafloor mapping frameworks. Global seafloor surveys record thousands of seamount features that compose these chain systems. When several chains appear across the same geographic sector and follow related directional tracks, they form multi-chain alignment sectors within the broader reference system of seamount distribution mapping. These sectors represent spatial groupings of multiple aligned seamount chains across defined regions of the ocean floor. Basin-spanning chain alignment fields refer to seamount chains that extend across large portions of an ocean basin while maintaining consistent directional orientation. These fields consist of long sequences of underwater elevations mapped along extended spatial tracks. The alignments appear across wide sections of ocean floor and form recognizable patterns in basin-scale seafloor mapping frameworks. Several alignment fields include chains that traverse large mid-basin regions from one geographic sector to another. Individual chains may extend across thousands of kilometers of seafloor while preserving a stable directional layout. These extended alignments produce long corridors of seamount features distributed across basin interiors. The continuity of these corridors contributes to the identification of basin-spanning alignment fields. Multiple chains may occur within the same basin-spanning field. In such cases, separate chains appear along similar directional tracks across adjacent parts of the basin. Each chain remains identifiable as a sequence of mapped seamount elevations, while the collective arrangement forms a broader alignment field across the ocean floor. The spacing between chains allows the parallel structure of the field to remain visible in bathymetric datasets. Basin-spanning alignment fields appear in several major ocean basins and include regions where long seamount chains cross large areas of deep ocean terrain. These fields often intersect multiple basin sectors and extend through several mapped seafloor zones. Their geographic extent makes them among the largest directional structures recorded in global seamount distribution mapping. Global bathymetric surveys document thousands of seamount features that contribute to these extended alignment systems. When a chain maintains a consistent directional path across large portions of a basin, it becomes part of a basin-spanning alignment field. These fields represent large-scale spatial arrangements of seamount chains across the mapped ocean floor. North Pacific cluster regions include several ocean floor areas where multiple seamount chains occur in concentrated geographic groupings. These clusters occupy wide sectors of the northern Pacific basin and extend across large portions of the ocean interior. Numerous mapped seamount sequences appear across these regions and form recognizable clusters within regional bathymetric reference frameworks. Several cluster regions occur across central and northwestern parts of the North Pacific basin. Within these regions, multiple seamount chains appear across neighboring areas of seafloor. Each chain forms a sequence of underwater elevations aligned along extended spatial tracks. When several chains occur within the same geographic sector, they form identifiable cluster regions within the broader basin distribution. Additional cluster areas appear across northeastern Pacific sectors, positioned between basin interiors and continental boundary zones. In these regions, mapped seamount chains appear across wide ocean floor fields distributed across northern Pacific latitudes. The chains remain identifiable as separate sequences of underwater elevations, while contributing to regional groupings across mapped seafloor grids. Some North Pacific clusters extend across large mid-basin plateaus and surrounding ocean floor regions. In these areas, several chains occupy neighboring sectors of seafloor terrain and form concentrated groupings of aligned elevations. The distribution of these chains across nearby areas contributes to the classification of cluster regions within North Pacific seamount mapping systems. Global seafloor surveys record many thousands of seamount features across the North Pacific basin. These mapped elevations appear within numerous chains that occupy defined geographic sectors of the basin. When multiple chains occur across the same regional areas, they form cluster regions that serve as reference zones in the global mapping of seamount chain distribution. South Pacific cluster regions include several areas of the ocean floor where multiple seamount chains occur in concentrated geographic groupings. These clusters occupy wide sectors of the southern Pacific basin and extend across large regions of open ocean terrain. Numerous mapped sequences of underwater elevations appear across these sectors and form recognizable cluster groupings in regional seafloor datasets. Several cluster regions occur across central sectors of the South Pacific basin. In these regions, multiple seamount chains appear across neighboring parts of the ocean floor and form concentrated spatial groupings. Each chain consists of a sequence of mapped seamount elevations aligned along extended geographic tracks. The proximity of several chains within the same regional area produces identifiable cluster regions within the basin. Additional cluster regions occur across eastern sectors of the South Pacific basin. In these areas, mapped seamount chains appear across broad ocean floor zones, extending toward continental boundary regions of the Pacific margin. The chains remain identifiable as separate sequences of underwater elevations, while contributing to regional groupings across mapped seafloor grids. Further cluster areas appear across southwestern Pacific sectors, where multiple chains occupy neighboring seafloor regions. These chains extend across wide areas of deep ocean terrain and form concentrated arrangements of aligned seamount features. The presence of several chains within the same geographic sector produces clearly defined cluster regions across the southern Pacific basin. Global bathymetric surveys record thousands of seamount features across the South Pacific Ocean. These mapped elevations occur within numerous chains positioned across different parts of the basin. When multiple chains occupy the same regional sectors, they form cluster regions that serve as reference areas in global seamount chain distribution mapping. Central Atlantic cluster zones include several regions of the ocean floor where multiple seamount chains occur in geographically concentrated groupings. These zones occupy sectors of the Atlantic basin, positioned between the continental margins of the Americas, Europe, and Africa. Numerous mapped sequences of underwater elevations appear across these sectors and form identifiable cluster areas within regional seafloor reference systems. Several cluster zones occur across central portions of the Atlantic basin interior. Within these zones, multiple seamount chains appear across neighboring parts of the ocean floor and form concentrated regional groupings. Each chain consists of a sequence of mapped seamount elevations arranged along extended spatial tracts. But the presence of several chains within the same geographic sector produces cluster zones that are clearly recognizable in bathymetric mapping datasets. Additional cluster zones appear across transitional sectors located between basin interiors and continental boundary regions. In these areas, mapped seamount chains occur across broad ocean floor zones, extending between the central Atlantic basin and surrounding continental margins. Individual chains remain identifiable as aligned sequences of underwater elevations while contributing to regional cluster groupings. Some Central Atlantic clusters extend across oceanic plateau regions and surrounding deep ocean terrain. In these locations, several seamount chains occupy neighboring seafloor sectors and form concentrated arrangements of mapped seamount features. These clusters appear as groups of aligned chains distributed across wide portions of the Atlantic basin interior. Global seafloor surveys record thousands of seamount features across the central Atlantic basin. These mapped elevations appear within numerous chains distributed across different parts of the ocean floor. When several chains occur within the same regional sectors, they form cluster zones that serve as reference areas for cataloging seamount chain distribution across the central Atlantic Ocean. Southern Atlantic cluster zones include several regions of the ocean floor where multiple seamount chains occur in geographically concentrated groupings. These zones occupy wide sectors of the southern Atlantic basin, between the continental margins of South America and Africa. Numerous mapped sequences of underwater elevations appear across these sectors and form identifiable cluster areas within regional seafloor mapping frameworks. Several cluster zones occur across central portions of the southern Atlantic basin interior. In these zones, multiple seamount chains appear across neighboring ocean floor areas and form concentrated regional groupings. Each chain consists of a sequence of mapped seamount elevations, arranged along extended spatial tracts. The proximity of several chains within the same geographic sector produces cluster zones, visible in bathymetric survey datasets. Additional cluster zones appear across western sectors of the southern Atlantic basin, positioned closer to the South American continental margin. In these areas, Mapped seamount chains extend across broad ocean floor regions and form groupings of aligned underwater elevations. Individual chains remain identifiable while contributing to the spatial concentration that defines each cluster zone. Further cluster regions occur across eastern parts of the southern Atlantic basin, located toward the African continental margin. In these sectors, several seamount chains occupy neighboring seafloor areas and create concentrated arrangements of mapped elevations. The grouping of multiple chains within the same regional sectors forms distinct cluster zones across these parts of the basin. Global bathymetric mapping programs document many thousands of seamount features across the southern Atlantic Ocean. These mapped elevations occur within numerous chains distributed across different sectors of the basin. When several chains occupy the same regional areas, they form cluster zones that serve as reference regions in global seamount chain distribution mapping. Western Indian Ocean cluster fields include several regions of the ocean floor, where multiple seamount chains occur in geographically concentrated groupings. These cluster fields occupy sectors of the Western Indian Ocean basin, located east of the African continental margin and west of the Central Basin interior. Numerous mapped sequences of underwater elevations appear across these areas and form recognizable cluster patterns within regional seafloor mapping frameworks. Several cluster fields occur across wide ocean floor sectors positioned between major basin interiors and continental boundary regions. Within these sectors, multiple seamount chains appear across neighboring areas of the seafloor and form concentrated regional groupings. Each chain consists of a sequence of mapped seamount elevations aligned along extended spatial tracks. The presence of several chains within the same geographic sector produces cluster fields that are visible in bathymetric datasets. Additional cluster fields occur across Western Indian Ocean sectors positioned near large oceanic plateau regions and surrounding basin terrain. In these locations, mapped seamount chains occupy adjacent parts of the ocean floor and form concentrated arrangements of aligned underwater elevations. Individual chains remain identifiable as separate sequences while contributing to the spatial concentration that defines each cluster field. Further cluster areas appear across transitional ocean floor sectors, linking Western Basin interiors with neighboring Central Indian Ocean regions. In these sectors, several seamount chains occur across wide seafloor zones and create grouped distributions of mapped elevations across the basin. Global bathymetric surveys record thousands of seamount features across the Western Indian Ocean. These mapped elevations appear within numerous chains distributed across different parts of the basin. When multiple chains occur within the same regional sectors, they form cluster fields that serve as reference zones in the mapping of seamount chain distribution across the Indian Ocean basin. Eastern Indian Ocean cluster regions include several areas of the ocean floor where multiple seamount chains occur in geographically concentrated groupings. These regions occupy sectors of the Eastern Indian Ocean basin, extending toward the Australian continental margin and surrounding ocean floor terrain. Numerous mapped sequences of underwater elevations appear across these sectors and form recognizable cluster patterns within regional bathymetric mapping frameworks. Several cluster regions occur across central parts of the Eastern Indian Ocean basin. Within these regions, multiple seamount chains appear across neighboring areas of the ocean floor and form concentrated spatial groupings. Each chain consists of a sequence of mapped seamount elevations, aligned along extended geographic tracks. The proximity of several chains within the same sector produces cluster regions that are identifiable in seafloor survey datasets. Additional cluster regions appear across southeastern sectors of the Indian Ocean basin, located near large oceanic plateau areas and surrounding basin interiors. In these areas, mapped seamount chains occupy adjacent portions of the seafloor and form concentrated arrangements of aligned underwater elevations. Individual chains remain distinguishable while contributing to the spatial concentration that defines each cluster region. Further cluster regions extend across transitional ocean floor zones, linking the eastern Indian Ocean basin with surrounding Southern Ocean sectors. In these areas, several seamount chains appear across wide seafloor zones and create grouped distributions of mapped elevations across the basin. Global bathymetric mapping programs document thousands of seamount features across the eastern Indian Ocean basin. These mapped elevations occur within numerous chains distributed across different parts of the ocean floor. When several chains occur within the same regional sectors, they form cluster regions that serve as reference areas in global seamount chain distribution mapping. A global chain distribution reference grid provides a spatial framework used to organize the positions of seamount chains across the world ocean. The grid aligns seamount chain locations within a coordinate-based structure that spans all major ocean basins. Each chain appears as a mapped sequence of underwater elevations positioned within defined grid segments of the global ocean floor. The reference grid relies on geographic coordinate systems that divide the ocean surface into indexed spatial units. Latitude and longitude coordinates provide consistent positioning references for seamount chains located across different basins. When chains are recorded in bathymetric datasets, each mapped seamount occupies a specific coordinate position within the global grid. The arrangement allows chains from distant ocean regions to be catalogued within a shared spatial system. Large-scale seafloor mapping programs contribute to the development of this grid-based reference structure. Multi-beam sonar surveys and satellite-derived bathymetric models provide positional data for thousands of seamount features. These observations allow chains to be placed into mapped grid segments that correspond to defined geographic sectors of the global ocean floor. Within the reference grid, seamount chains appear as linear sequences distributed across multiple grid cells. Some chains occupy a limited number of grid segments, while others extend across larger sections of the ocean floor. The grid framework records these placements without assigning geological interpretation or formation context. The Global Chain Distribution Reference Grid functions as a cataloging structure for mapping seamount chains across all ocean basins. Each chain is indexed according to its position within the coordinate grid and associated basin sector. The system provides a standardized framework for organizing seamount chain placement within global seafloor mapping datasets. Interbasin chain distribution corridors refer to geographic pathways where seamount chains extend across boundary regions between major ocean basins. These corridors appear as continuous or semi-continuous alignments of underwater elevations mapped across wide ocean floor sectors. The corridors provide spatial reference structures that link chain distributions from one basin region to another within global seafloor mapping systems. Several interbasin corridors occur in ocean sectors where basin boundaries meet or transition across large areas of open ocean terrain. In these regions, mapped seamount chains appear along extended geographic tracts that cross basin classification boundaries. Individual chains may continue from one basin reference sector into another, while maintaining a consistent spatial alignment. The continuity of these chains contributes to the identification of distribution corridors across basin transitions. Multiple chains may occupy the same corridor region. In such cases, separate sequences of seamount elevations appear across neighboring ocean floor tracts that follow similar directional paths. Each chain remains identifiable within bathymetric datasets, while contributing to the broader corridor pattern across basin boundary sectors. The grouping of several chains within the same pathway strengthens the recognition of these corridors within global distribution grids. Interbasin corridors appear across several ocean regions where basin systems connect through wide seafloor transition zones. These corridors extend across large mapped sectors of the ocean floor and may intercept multiple regional grid segments used in global bathymetric classification systems. Seafloor mapping programs record thousands of seamount features within these corridor regions. When chain sequences extend across basin boundaries and follow related spatial tracks, they form interbasin distribution corridors within the global reference grid used to organize seamount chain placement across the world ocean. Oceanic margin chain reference sectors identify areas of the ocean floor located near the boundaries between ocean basins and continental margins, where seamount chains appear in mapped groupings. These sectors occur along large ocean floor regions adjacent to continental edges and extended basin margins. Seamount chains located in these areas are catalogued within global distribution grids as part of margin-adjacent reference sectors. Several reference sectors occur along the margins of major ocean basins, where oceanic crust extends toward continental boundary regions. In these sectors, mapped seamount chains appear across wide seafloor zones, positioned between basin interiors and continental slopes. Each chain consists of a sequence of underwater elevations aligned along spatial tracks that occupy defined portions of the ocean floor grid. Multiple chains may occur within the same margin reference sector. Individual chains appear as separate sequences of mapped seamount features, distributed across neighboring parts of the seafloor. The grouping of several chains within these sectors creates identifiable patterns of distribution across oceanic margin regions. Oceanic margin sectors also include transitional seafloor areas, where basin interiors connect to continental boundary zones through extended ocean floor terrain. In these regions, mapped seamount chains occupy broad geographic sectors and appear across grid segments positioned near continental edges. The chains remain identifiable within bathymetric datasets while contributing to regional groupings within the distribution grid. Global bathymetric mapping programs document thousands of seamount features located near oceanic margins across multiple basins. These mapped elevations appear within numerous chains distributed across margin-adjacent sectors. When chains occur within these boundary regions, they form oceanic margin reference sectors within the global grid used to organize seamount chain distribution across the ocean floor. Mid-basin chain distribution zones refer to areas of the ocean floor located within the interior portions of major ocean basins, where seamount chains occur in mapped groupings. These zones occupy wide regions of deep ocean terrain, positioned far from continental margins and basin boundary sectors. Seamount chains located in these regions are catalogued within global distribution grids as interior basin reference zones. Several mid-basin zones occur across the central regions of major ocean basins. Within these zones, mapped seamount chains appear across large sections of the ocean floor and form identifiable groupings of aligned underwater elevations. Each chain consists of a sequence of mapped seamount features arranged along extended spatial tracks that cross broad portions of the basin interior. Multiple chains may occupy the same mid-basin distribution zone. In such areas, individual chains appear as separate sequences of underwater elevations positioned across neighboring sections of seafloor terrain. The presence of several chains within the same geographic zone produces recognizable regional groupings across mapped ocean floor grids. Mid-basin distribution zones extend across large areas of deep ocean terrain that form the central sectors of ocean basins. These zones may include multiple grid segments within global bathymetric classification systems. Seamount chains located in these regions are recorded across wide geographic sectors that represent the interior structure of basin-scale seafloor terrain. Global seafloor mapping programs document thousands of seamount features across mid-basin regions of the world ocean. These mapped elevations appear within numerous chains, distributed across central ocean floor sectors. When chains occur across these interior areas, they form mid-basin distribution zones within the global grid used to catalog seamount chain placement across the ocean floor. Polar interface chain regions refer to ocean floor sectors located near high-latitude areas where major ocean basins approach polar geographic boundaries. These regions occur across northern and southern sectors of the global ocean and include wide areas of deep ocean terrain positioned near polar transition zones. Seamount chains mapped within these regions are catalogued as part of the global distribution grid used to organize seafloor features. Several polar interface regions occur in sectors where ocean basins extend toward Arctic and Antarctic latitudes. Within these regions, mapped seamount chains appear across broad areas of ocean floor, positioned near the outer limits of basin interiors. Each chain consists of a sequence of underwater elevations arranged along extended spatial tracts that occupy defined portions of the global grid. Multiple chains may occur within the same polar interface region. Individual chains appear as separate sequences of mapped seamount features positioned across neighboring sections of seafloor terrain. The grouping of several chains within these high-latitude sectors produces identifiable regional patterns across mapped ocean floor grids. Polar interface regions often occur across areas where several basin sectors approach high-latitude ocean boundaries. In these regions, mapped chains occupy grid segments that connect basin interiors with polar ocean sectors. The placement of these chains contributes to the classification of polar interface regions within global seamount distribution frameworks. Global bathymetric surveys document numerous seamount features located across high-latitude ocean sectors. These mapped elevations appear within chains distributed across polar-adjacent parts of the ocean floor. When chains occur within these high-latitude sectors, they form polar interface chain regions within the global reference grid used to catalog seamount chain placement across the world ocean. The global chain network layout represents the overall spatial arrangement of seamount chains across the world ocean. This layout places individual chains into a unified global framework that spans all major ocean basins. Each chain appears as a mapped sequence of underwater elevations positioned within defined geographic sectors of the global seafloor grid. Within this layout, seamount chains are distributed across multiple basin regions, including central basin interiors, oceanic margins, and high-latitude sectors. Chains, located in different parts of the ocean, are organized within mapped grid segments that correspond to basin-scale classification systems. The arrangement allows chains from distant ocean regions to be catalogued within a single spatial reference structure. The network layout records the geographic placement of chains using coordinate-based mapping systems. Each mapped seamount occupies a defined location within global bathymetric datasets. When seamount features align to form chains, these sequences appear as linear elements within the broader global distribution network. The layout, therefore, consists of numerous chain sequences distributed across the ocean floor. Multiple chains may appear across neighboring parts of the global grid. Some chains occupy limited regional sectors, while others extend across wider sections of ocean floor terrain. The network layout captures these placements by organizing chain positions according to grid-based geographic references rather than geological interpretation. Global seafloor mapping programs document thousands of seamount features that contribute to this worldwide network of chains. These mapped elevations appear within many chain sequences, distributed across several ocean basins. The global chain network layout provides a structural framework used to catalog the placement of these chains across the planetary ocean floor. Across the world ocean, seamount chains form a widespread pattern of underwater mountain alignments. From large basin interiors to remote ocean sectors, these chains appear across many regions of the seafloor, creating a global network of mapped elevations. As ocean mapping continues to improve, the geographic patterns of these chains become clearer within the larger structure of the planetary ocean floor.